Chapter 14, Data Storage and Disaster Recovery. Bear with me on this chapter, it is long and in-depth, but we will get through it. The storage of images and any electronic health information is a very important step in implementing PACS. It is relatively hard to guess how much storage a department will need, mostly due to the fact that new technologies and studies arise and are used on an ongoing basis, and they are usually much larger in data and as well as in images. Generally, though, when purchasing storage, it is something that is done independent of the PACS vendor. We will talk about different rules in regards to the storage management. The IT department is primarily responsible, and this includes funding, providing infrastructure, hardware and software, and meeting administrative and clinical departments' requirements. The requirements could include storage, periodic hardware or software upgrades, 24/7 accessibility, adhering to HIPAA and other mandated security and retention requirements, and also providing disaster recovery and business continuance. The administrative and clinical departments, they need to work with IT to ensure applications run smoothly. They are also responsible for setting realistic response times for the information queries, and are responsible for estimating storage requirements that they may need. This is typically estimated at a 12 to 18 month period. The chief financial officer, they need to be able to understand storage management and what the ongoing cost is. As you know, for a CFO, cost is their number one priority, but the CFO needs to allocate any necessary funding for storage management. They need to also understand that the life cycle of many of the PACS components, including the storage management, is on a 3 to 5 year life cycle due to parts of it becoming technically obsolete as new technologies arise. So we will discuss the finances of storage now. Just remember that storage management is a recurring cost. It needs to be budgeted for annually. Regarding the hardware, infrastructure, and software, this is something that is initially purchased up front, but there are maintenance and licensing fees, and as well as replacement costs. Replacement costs are due to the system becoming technically obsolete, and just due to the fact that technology is ever changing. You need to prepare for storage media costs, which are usually only 5 to 10% of the total cost. Personnel needed. Utilities, including power and air conditioning and warming systems. The cost of space in a secure data center. You need to also account for any data backup that is necessary and the replication of data, as well as any data that may need to be migrated. When in regards to storage, imaging data can be divided into two groups, variable content files and fixed content files. Variable content files are data that may change after stored. This includes RIS, HIS, and demographic databases of PACS. This takes up about 5% of storage. Fixed content files includes data that won't change once it's been stored. This consists mostly of DICOM objects, and it stays on the modality usually for at least 1 or more days, depending on how many exams you do. The modality copies the images immediately to Tier 1 storage, which is PACS managed, and it is stored for 3 to 15 months. And it also consists of the PACS forwarding a copy to Tier 2 storage for long-term storage. This is copied to storage at a remote place, or it could be copied to media and taken off-site to Tier 3 storage for disaster recovery purposes. As you can see, the fixed content files have a pretty extensive storage process, and typically about 4 copies of a study exist until it is eliminated on the modality. Health Information Portability and Accountability Act. I know you've all heard of this before. We will talk a little bit more in depth about HIPAA in Chapter 18, but I will touch on its importance to electronic protected health information storage requirements a little bit right now. This covers the confidentiality, integrity, and availability of electronic protected health information. since April 21st of 2005. It covers EPHI stored on any type of storage media. This includes portable computers, anything transmitted electronically via the internet. This includes emails and text messages as well. It requires electronic protected health information stored on media or transmitted electronically to be encrypted, which makes it secure. It needs to be encrypted during transit and when it is stored on the physical media. And it also, whenever there is a possibility that it can be accessed by unauthorized individuals. HIPAA requires that 2 copies must exist in case one is destroyed, so 2 copies of every exam have to be out there. And electronic protected health information should be stored in a way that doesn't allow any unauthorized modification, such as a write once, read many types of storage. This ensures that the original data cannot be rewritten over. I want to talk a little bit about the retention requirements of electronic protected health information. It is usually kept 5 to 7 years or longer, and it is dependent on the type of electronic protected health information that it is. It's also dependent on the age of the patient. For example, the electronic protected health information of minors is kept until the patient is 21 years old. It is regulated by federal statute, and it varies by state and provider. And you must comply with the state's statute of limitation, which is that EPHI is usually kept for 2 years following the patient's death. Then there are destruction requirements. EPHI has to be destroyed until there is no possibility of any reconstruction of the information that was on it. The most cost-effective option is to simply just keep it permanent in the storage. The destruction must be documented. The destruction of EPHI must be documented, including the date of destruction, the method of destruction, the description of disposed records, inclusive dates covered, the statement saying the records were destroyed using a normal process, and as well as the signature of the individual supervising and witnessing the destruction. An example of destructing electronic protected health information would be just simply shredding a CD or DVD that contains EPHI. A few things you will need to keep in mind when selecting storage media includes functionality, which is what is the response time like to read and write information on it. The longevity, so how long will the media be available and be supported by technology. The total cost of ownership, so what is the total cost of purchasing and supporting the storage management system. The cost of the media itself. Durability, so what is the wear and tear like on the storage media. And compliance features, is it compliant with HIPAA requirements. Now we will talk about a few different types of storage media. There is optical media, which is mainly used for patient copies. So if a patient calls in, requests a copy of their exam, this is typically what departments use to put the exams on and give them to patients. It is low cost. It maintains the integrity of the information for long term if it is properly handled. The lifetime is 6 years due to technology becoming obsolete. Data on it is usually write once, read many format, which is HIPAA compliant, remember. And examples of optical types of storage media are CDs and DVDs. CDs are available as write once, read many, and also as a rewritable version that must not be used for storage of medical information. With DVDs, there is a readable version, which is a DVD-R, and there is a readable writable version, which is DVD-RW. It is important to know that only the DVD-R version should be used to store medical information. Magnetic tape media is usually only used anymore for the Tier 3 storage, database backups, and hardly ever used for Tier 2 storage. You must use them with tape drives, which become obsolete within 5 to 6 years. The bad thing is that the media usually lasts longer than the tape drives themselves. They're available in many physical and storage formats. They are also available in uncompressed or in lossless compression format. And they can be written in a write once, read many format. Spinning magnetic disks are another type of storage media. Also, there are redundant array of independent disks, which is called RAID. This is data storage that combines multiple physical disk drive components into a single unit. The reason for this is usually for data redundancy and for performance improvement. There is content addressable storage, which is storage based on its content, and it's used for fixed content files. There are massive array of idle disks, which is MAID. This is designed for write once, read occasionally kind of format. The drives only spin on demand. It has a high storage density, and it is considered to have a lower cost, as well as electrical power and cooling requirements versus the RAID type of storage media. The MAID is primarily used in disaster recovery for Tier 3 and Tier 2, and it can supplement or replace tape libraries. There is also solid state media. This includes memory sticks or flash drives, and this type of media may begin to replace the spinning magnetic disks soon. Image compression, as you can see, seems to come up in many chapters. We'll just do a quick review, although I want you to read more about it on page 234 of your book. The reasons for compression is that it allows for a decrease in transmission time of the images. So remember, it decreases the bandwidth requirements for the transmission of images. It decreases storage requirements for images, and it is a reduced cost for storage management and infrastructure. Remember, two types of compression. There's the lossless and the lossy. That is coming up again. The lossless, remember, is where all the original data is preserved and can be reestablished. And lossy is when data is lost and cannot be reestablished. So disaster recovery is extremely important. There are factors to consider when selecting the storage management for disaster recovery. It includes capacity, so amount and type of data to be stored or shared. The performance, so the input and output and throughput requirements. The scalability, which is long-term data growth. Availability and reliability, so how mission critical is the application. The data protection, so backup and recovery requirements. IT staff resources and capability, so is your IT staff well trained and do they have time to set aside outside of their normal duties in case a disaster recovery occurs. And the upfront and annual budget allocations. Disaster recovery and business continuance are absolutely mandatory if you have a PAC system. So the HIPAA regulations requires disaster recovery of retrievable exact copies of the electronic protected health information. Disaster recovery usually only happens if there is a component failure, such as like a server, storage system, media, data corruption, human error, virus, or a system breach. Or if there is a catastrophic event, which this is always a minimal chance, but the catastrophic events such as power failure due to rain, snow, ice, floods, hurricanes, any natural disasters, or even a terrorist attack is considered a catastrophic event. So what is the difference between disaster recovery and business continuance? Disaster recovery will restore or recover the electronic protected health information lost as a result of either a component failure or the catastrophic event. But business continuance will provide availability to access the electronic protected health information that is lost as a result of a component failure or from the catastrophic event. So disaster recovery deals with restoring or recovering the EPHI, and the business continuance deals with accessing the EPHI once it is lost. So there are a few different options out there that sites have for disaster recovery options. One is a tape backup. This is where the data is off-site in a fire and heat-proof safe with a secure storage vendor, and it doesn't minimize the downtime. This is usually the least expensive option, but also poses a high risk to the healthcare facility. A hospital can back up in the second secure data center, which is operated by a healthcare facility, usually over 100 miles away. This helps minimize downtime. They can rent space and functionality at a Tier 3 or Tier 4 data center that is 100 or more miles away. This is expensive since hardware and software must be purchased and the data center services must be leased. They can store data in multiple data centers owned by the healthcare facility. This also helps minimize downtime. And they can outsource management and the storage of disaster recovery and possible long-term storage as well as business continuance to a storage service provider. This is the most cost-effective solution, and also it minimizes the use of physical and personnel resources for the healthcare facility. There are basic requirements for the business continuance plan. You must practice and document workarounds for the system component failures. So you could hardwire at least one of each modality to a DICOM printer in case of a failure. And then you can download all necessary studies to a computer in a surgical suite prior to starting a procedure. Those are just a few examples. Another requirement is to eliminate single points of failure in the infrastructure. This includes routers, switches, application gateways, and interfaces. Another requirement is to alternate and test the backup of the power sources. This means both interrupted power sources, which must be checked weekly, and also automated emergency power generators. Another requirement is to have a test server. A site should keep a copy of the database restored on a test server, and it should be tested at regular intervals to establish its integrity. Disaster recovery and business continuance add to the cost of the digital environment. No doubt about it, since they are both a must, obviously they're going to add to the cost. Sometimes you can't avoid downtime, and system downtime affects a few things. Usually it is patient care, productivity, finances, as in lost revenue, continuing expenses, and cash flow. And it could affect public relations. So like the patient's staff, referring physicians, and the general public. What will they think if you have a catastrophe and lose their images and their reports? I don't think they'll be very happy. You should think of disaster recovery and business continuance as a kind of downtime insurance. This is a form of risk management. So data migration sometimes has to take place, maybe because there's a new PACS purchase and a site needs to migrate all of their data from the previous PACS to the new PACS. Possibly an upgrade of an existing PACS needs migration. Maybe converting from silos of storage to enterprise storage, or possibly just from upgrading obsolete technology of the storage components. Data migrations may slow down clinical applications. This happens because it requires access to the same database and the storage system that PACS needs to access for the clinical applications. And it would be nice for it to occur on evenings and weekends if that's a possibility for a department. This is just because the patient throughput and PACS utilization is at a minimum during these times. So data migrations can either take place by the vendor or by the IT department. The IT department usually does this, but it will take away from their daily duties as they focus on the migration. You also need to make sure ahead of time that using your own IT department doesn't void the warranty on the new PACS system by the vendor. If the vendor is going to do the migration, make sure you check their references. Make sure that they have done a reputable job in the past at other places that have had a similar clinical and data environment. Say you're in a situation where you have an existing PACS system with a current vendor, but are purchasing a new PACS system with a new vendor. It is often possible to have either vendor perform the migration, so either the old vendor or the new vendor. But just be cautious and aware that the current vendor really has no reason or incentive to perform an effective data migration according to accuracy, speed, and cost. They are losing your business to the new vendor. The new vendor does have an incentive, which is to please you, the client, and will most likely perform a successful data migration. And it is not unheard of that if there are issues with data migration, the old and the new vendor will often point fingers at each other, blaming the other for any issues. There is also the option to go with a neutral vendor, one that specializes in migrating DICOM objects, and this way the third vendor is not biased towards either the old or the new vendor. They just want to get the job done and to do it right. It is important to make administration aware that data migration costs money. It is usually very expensive, and oftentimes they are not fully clued in on the need and the costs of the data migration. Let them know about this in advance when purchasing a new PAC system. Example, it can cost as much as $200,000 and take over 6 months to complete. This is something they want to know about ahead of time. Data migration cost is dependent upon a few things. Does the data to be migrated have to be cleansed of DICOM headers and database? Is the data in a non-proprietary format? The method used to migrate the data? And the cooperation of the new and the old vendor. Are they going to work cohesively together? The existing PACS vendor may charge a fee to facilitate migration.